Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In the last lecture, you learned about the cloud service models of infrastructure as a service, platform as a service, and software as a service. In this lecture, you'll learn about the cloud deployment models as defined by the NIST. That's public cloud, private cloud, community cloud, and hybrid cloud. So the first one to cover is public cloud. The definition is the cloud infrastructure is provisioned for open use by the general public. It may be owned, managed, and operated by a business, academic, or government organization, or some combination of them, and it exists on the premises of the cloud provider. So public cloud are all the really well-known cloud providers like Amazon Web Services, Microsoft Azure, IBM Bluemix, and Salesforce. The first three do support all of the different service models. Salesforce specialize in software as a service, but they're still all public cloud providers. And public cloud is by far the most common deployment model. The next type is private cloud. The definition of this is the cloud infrastructure is provisioned for exclusive use by a single organization, comprising multiple consumers, for example, business units like departments within that company. It may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premises. So private cloud could be where you've got a large company and they're providing cloud services to their own internal departments. Those cloud services could be managed by the company themselves, or it could be managed externally by a third-party provider. The main point is that these cloud services are dedicated for that one organization. It's not a public cloud where anybody can go and use that. Private cloud works the same way as public cloud, but the services are provided to internal business units usually, instead of to external public enterprises. Private cloud fulfills the cloud essential characteristics. So this is how it's different than a traditional on-premises solution. Because you might think, well, private cloud, that's a company and they're owning and managing their own infrastructure and providing support for their own internal departments. Well, they were doing that already anyway with on-premises solutions. So how is a private cloud solution any different? The reason is that it fulfills the cloud essential characteristics. Those were on-demand self-service, rapid elasticity, broad network access, resource pooling, and measured service. So if you think back to the example when I gave you the demo of Amazon Web Services, which was on public cloud, well, an organization could develop something like that for their own internal use. With the traditional on-premises model, a business unit orders a new server by raising a ticket with the IT department. The server is then provisioned and configured by the server, network, and storage teams as separate manual processes, and it will typically take over a week. With private cloud, a business unit orders a new server typically through a web portal, just like you saw me doing it for Amazon Web Services. The server is then completely automatically provisioned without requiring manual intervention. Again, just like with AWS. So it works the same way, but rather than being for public external customers, this is for your own internal business units. The company will use automation software such as Cisco UCS Director. So again, remember when I was talking about AWS, and we said that there was that front-end software, which is usually managed, is usually configured through a web-based GUI, and that's what gives you the self-service. That then talks to other software, which talks to the actual hardware infrastructure devices, like your firewalls, your routers, your switches for the networking, your storage system for the storage, and VMware or Hyper-V or Citrix for the server provisioning. That front end software and the software just behind that, you can use something like UCS Director, which comes from Cisco for that. There's also companies like BMC and CA Technologies that do that as well. So they can do the automation software, which talks with the front end and then talks with the back end as well. There's another component that is going to be used for the automation of the networking configuration, and that is an SDN controller, software defined networking. Cisco have a few different SDN products available, including DNA Center. I'll be covering software defined networking and DNA Center later in the network automation and programmability section. Private cloud is most suitable for large companies where the long-term ROI and efficiency gains can outweigh the initial effort and cost to set up the infrastructure and automated workflows. To set up private cloud is a lot of work because you need to design software that is going to automate all of this. You need to test it. You need to set up all of your different workflows. So it's a really big amount of work up front. But once that work has all been done, you've seen that you can very quickly automate the provisioning of a server. Just like we did with AWS, we could just click from drop downs and just put in basic information. It took a few minutes to fill that information in, and then the server would be up and running in around 15 minutes. That's way quicker than doing it the traditional way, which will normally take about a week or longer to provision a new server. So you get the big benefit in the end, but it's a lot of work to be able to set that up. So typically it's only going to be large companies which are going to have the resources to be able to do this. That might change in future as new software comes out and makes this easier, but for now it's mostly large companies that would have private cloud. Companies with private cloud don't usually advertise that fact because it's private. So there's not really many examples I can give you of private cloud. But one is US Department of Defense on private cloud provided by AWS. So that's an example of private cloud owned, managed, and operated by a third party. The third party is Amazon, and they provide cloud services to the US Department of Defense, but that infrastructure, it's on separate physical infrastructure that is only used by the US Department of Defense. It's not shared with anybody else. While we're talking about private cloud, something to mention here, some public cloud infrastructure as a service providers will sometimes market dedicated servers as private cloud. Dedicated servers means that the actual server hardware is dedicated for a single customer. On that one physical server, there's not other customers running on there. But it's not private cloud because even though that server hardware is dedicated for one customer, all of the supporting infrastructure like the switches, the routers, the storage system, etc. is shared. So they might market it as private cloud, but that's not really private cloud. Okay, the next one is community cloud. The definition of this. The cloud infrastructure is provisioned for exclusive use by a specific community of consumers from organizations that have shared concerns. So private cloud is just a single organization. Community cloud is a shared community. This is by far the least common deployment model. It is, however, sometimes used in government environments. So again, this would really only make sense for government where they're huge organizations and there's separate, really large government departments that can come together and share a community cloud. The last one is hybrid cloud. Definition of this. The cloud infrastructure is a composition of two or more distinct cloud infrastructures. So it's a mix between private, community, or public that remain unique entities but are bound together by standardized or proprietary technology that enables data and application portability. For example, cloud bursting for load balancing between clouds. So really there's the three types. There's private, community, and public. But if you mix and match any of those, that would count as hybrid cloud. So an example of this is that cloud bursting that was mentioned in the definition. So if a company has got their own private cloud infrastructure, but there's only so much of it, they've only got so much hardware. If they're running out of space, the option could be they could buy more hardware, but maybe it's just not possible to do that in their data center anymore. So a way that they can scale out of their own private cloud infrastructure is they can then spill over into using public cloud to get that additional capacity. So that's what cloud bursting is. You've got your own internal cloud and you burst out to use an external public cloud as well. An example of where this is sometimes used is a company could also have their own private cloud at their main site and use public cloud for their disaster recovery solution. So they've gone to the expense of building their own private cloud environment in their own data center, but they're worried that there might be some kind of regional disaster that takes out that data center. So they want to have a disaster recovery site that they can fail over to. They don't want to go to that huge expense of building the other data center again, so they could use a public cloud provider for that. Okay, so that was all of the different types. I'll see you in the next lecture for the last lecture in this cloud computing section, where I'll summarize all the advantages that you get from using cloud. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.